Okay, in order to work out this question, we are going to learn how to integrate these two expressions that we are having here. And you can see they are involving what we call trigonometric functions. And we shall start by saying, well, this part that we have here, we can be able to relate it to the u. So we can say, let u be equals to sine 2x plus 3. So in order to simplify this further, we are going to differentiate this part and this part. So differentiating u, because u is a function of x, we are going to have du is equals to, differentiating this, you start by differentiating the inner function. So you are going to get basically 2. Then differentiating a sine, we are going to get a cosine. Then it will be 2x. But differentiating this, we are going to get 0. Then we shall write now dx like that. So which means that in this expression here, I want you to see that we are having sine 2x plus 3 raised to power 2 cos 2x dx. But at this point, we are having du equals to 2 cos 2x dx. So I will want to ensure that I'm having cos 2x on one side and only. So meaning that this one we can be able to divide by 2, divide by 2 here. This and this will cancel out. So this will mean that cos 2x dx can be replaced with this part that we are having here, which is a half du. So meaning we shall replace also this one with u, because we had said let u be that. So our integral becomes u raised to power 2, then cos 2x dx, we are going to replace with that with a half du. And this can simplify to 1 over 2 u squared integral du like that. So we can now be able to apply the normal integration technique for polynomials. And to do that, if you are integrating an expression with power 2, you are going to have your u there raised to power 2 plus 1. Then down here we shall have 2 plus 1 as well. Then we shall say plus c. So finally, this is going to be 3, and that will be 1 over 6 u raised to power 3, then plus c. But you cannot be able to leave your answer at this point because the expression was in terms of x. So meaning that we are going to replace the value of u. So it will be 1 over 6 into sine 2x plus what? Plus 3 raised to power 3 raised to power 3, then you shall say plus c like that. So basically that's what this expression reduces to when you are performing the integration. Okay, we have this one here, and this one we are going to also use substitution, because if I let, you can see, if I let u be equal to sine x, what am I going to have? If I let u to be equal to sine x, what am I going to have? If I differentiate, I'll have the cos, which is here. So that's the objective. I let u to be sine x, so that if I'm going to differentiate it, it's going to give me this cos that we have here. Then let's differentiate. To be du is equals to du, differentiating u because it's a function of x, it becomes du. Differentiating sine x, you get cos x dx. So meaning this expression can be written as sine power 4x cos x dx. We can be able to write it this way. Then once we have written it this way, we can be able to substitute, because we are having cos x dx at this point. It will mean that if you are having x dx, you can be able to replace it with what? You can be able to replace it with this value, that du that we have at this point. So let's write it in terms of u. This will be integral of u raised to power 4 du. All right, because the cos x dx can be written as du. So we have our integral in terms of u. So once you have this, you can be able to perform the normal integration technique for polynomials. So which will mean that this is going to be u power 4 plus 1 over 4 plus 1, then plus c at that point. So once we have this, we can now say our expression reduces to u power 5 over 5 plus c, which will mean that this expression will be in terms of x, we are going to have 1 over 5 sine x power 5, then plus c. But when it's written like this, we can be able to write it also as 1 over 5 sine power 5 x plus c. Now, that is the final answer for this kind of expression. Yeah, we are going to integrate this. So meaning that we are going to say let u be equals to tan x. Let u be equal to tan x. Then if we are letting u to be tan x, we differentiate both sides. So du is going to be equals to sec squared x dx. Because if you differentiate this, you're going to get sec squared dx. And basically that's what we are having at this given point here, right? So which will mean that when we're going to write this integral, we are going to say it's going to be tan cubed x sec squared x dx. So this part that we are having here can be replaced with du that we are having at that point. Yes. So meaning that we can be able to write this integral in terms of u. So it will be integral of u raised to power 3 because u was tan x. So this one it means is tan x raised to power 3. And then this will be du. Then we can now be able to perform the normal integration technique. So this is going to be u raised to power 3 plus 1. And here we shall have 3 plus 1. Then we shall say plus c. Finally, this becomes u raised to power 4 over 4 plus c. But remember our u was what? Tan x. So our final answer becomes 1 over 4 tan raised to power 4x, then plus c, like that. So that is how you can be able to use use substitution in order to perform this particular question. And if you are finding value from this particular channel, consider subscribing so that anytime I'm going to upload further tutorials, you'll be notified. By so doing, you'll be supporting Proflan so that we can be able to reach more students and those who can be able to benefit more on that. At the same time, when I be creating another video, you will be able to be notified. In Proflan YouTube channel, I do matters physics and math so that I can be able to support you guys as you are doing your O level and A level courses, that is Cambridge and EdExcel. Now, what about this question here? What about this question here, whereby we are told that cos x squared, we're supposed to integrate cos x squared cos squared x dx. So the first thing that you need to do here is to say, let u be equals to cot x. Then once you have done that, you are going to say du, this one is going to be cosec, negative cosec squared x dx. Now you can see here we are having what is on this part, but the challenge is whatever we are having here is positive, but whatever we are having here is negative. So we shall multiply by -1. We multiply also this by -1. So multiplying it that way, we are going to have negative du is equals to positive what? Cosec squared x dx. Now, I can be able to comfortably replace this with whatever I'm having here. So let me just write that integral. It's cot squared x cosec squared x dx. So this part that I'm having here can be replaced with what? Du, because cosec squared dx is equal to negative du. So I'll be able to say therefore this is going to be u squared because cot was just u. So and this is cot squared, it will be u squared negative du. Yeah, and that will mean that a negative u, I'm integrating negative u, or I can even just integral of negative u squared with respect to u. Then I can be able to integrate this normally to be negative u raised to power 2 plus 1 over 2 plus 1, then plus c, like that. So once we have this, we can be able to say therefore this is going to be minus u power 3 over 3 plus c, which is the same as minus 1 over 3 u power 3 then plus c, which will mean what? Which will mean that minus 1 over 3 cot x, of course this is squared, then plus c. But if this squared, no, it's not squared but cubed, but this cubed like this is the same as negative 1 over 3 cot cubed x then plus c as our final answer. Basically, you're gonna just do it that way. So